Welcome to Notes 9.3, Essential Skill Z3, the Binomial Theorem. The Binomial Theorem is a way to raise binomials to exponents. It is a way to do it directly. By that, I mean that we can raise a plus b to the 6th power, the 7th power, or the 8th power without going through all the previous powers. Before, we had to FOIL out a plus b squared. Multiply it out, take the result, if we wanted a plus b cubed, bring this down, and redistribute it. A lot of computation if we needed to get higher powers. Binomial theorem avoids that, and it provides a nice application of sigma notation. A word about vocabulary. The binomial coefficients are the numbers that appear before the variable terms. We're going to use a special notation for the binomial coefficients, and we're going to count them starting at 0. For example, for 2, it's going to be row 4, term number 2. We count the rows starting at 0. For 5-1, we look at row 5, term 1, not term 0. We'll see more of that shortly. This is what the binomial theorem looks like. It contains a sigma, and just to get used to what this does, we're just going to do some substitutions. We're not going to resolve any of the binomial coefficients just yet. We're just going to apply our sigma notation rules. If we raise x plus 1 to the 3rd power, we're going to look at what this corresponds to in the binomial theorem. X is a, b is 1, n is 3. To start with, I'm going to rewrite the binomial theorem with the specifics of this problem. We'll resolve this expression by making a table. To get our final answer, we simply find the sum of all these terms. We'll look at replacing the binomial coefficients in a bit. This example is a little more complicated, but it's very doable if you want to skip ahead and try it before I finish. Notice the parentheses. It's very easy to make errors if you don't substitute using parentheses. The entire expression gets raised to the 5 minus k or the k power. Again, we'll make a table. Notice half our terms are going to be negative just because of the way the opposite of y raises to powers. Our final answer is going to look like this. That's a very lengthy expression, but we're raising a binomial to the fifth power. We should expect to have 6 terms. Now we're going to look at how to put together those binomial coefficients. We can construct Pascal's triangle, and it's going to give us those coefficients directly. Watch as I follow these rules. Here are some examples for you to try. Remember that we count from 0, just like on the first page. Now we put it all together. Notice that our binomial coefficients are all from row 3. When we expand this in its entirety, we'll be using row 3 and only one row 3. And that makes it easy to look at. We can also use the binomial theorem to pick out one single term. Let's say we only want the fourth term of the expansion of x minus 2 to the fourth. When we pick out the fourth term, that's the fourth term that we would count from the left. Remember, we start with the 0th term. Once we have a k value for the fourth term, all we need to do is plug it in to the expression as if we were only doing k equals 3. That's it. You may want to try this last example before I get to it. Thank you for watching. I'll continue with the extra examples in a separate video.